when we see or what is the keyword that we need to look for in terms of the problem that we have. Okay, so number one, they ask you when counting the number of ways that you select the item from a group, you need to consider of two keywords. What are the two keywords? Which is, again, the two keywords that they ask you is, does the repetition, does the item, can you repeat the item, right? The repetition allow, right? The other thing is, does the order matter, right? Those are the two items. Is, again, they will ask you, can you reuse the item, or does the order matter? So if we know that if the order matter, like number two, if the order matter, which is in this case, what will we think in terms of? Which is, if the order matter, we have to think in terms of permutation, which is, again, the order, the ranking, or specific title, right? And if the order does not matter, does not make a difference, then we know that that is a combination, right? So those are the two items, which is permutation, combination. On top of that, there's a fundamental counting principle. So again, looking at this thing here, they ask you for number 4, and like I say, I very doubt that they will ask you about the definition. It's just that easy for us to communicate in terms of this item here. So number 4, they ask you, an exclamation mark is referred to. Hopefully you guys say, well, this is a factorial, right? Because n factorial, and it represents the number of ways that you can arrange your item, right? The n factorial, which is, again, how many items we have, and that is the different ways in terms of arrange them where the order matter, right? The first item, for instance, let's say a factorial. What is a factorial? A factorial is basically tell you that you have a item. How many ways can you arrange those a item in terms of first, second, third, fourth, and so on and so forth, which is reminder a factorial is basically 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? Or your calculator, you just press 8 exclamation mark, and you should have 40,320 different ways, right? So again, we went over this thing here. As you will see the review, I don't show you the way to type it in your calculator. If whoever have question, send me an email and I will tell you or show you how to use your calculator to input or use your calculator to calculate this item here. And again, 0 factorial, just go back. 0 factorial is equal to 1, meaning if you have 0 item, there is one way you can order them, which is nothing at all, right? So again, that's the item we have, which is n factorial. Is basically now, instead of the number, it's just n, right? N times n minus 1 times n minus 2, so on and so forth in terms of those. So like I say, this is just to review or to go back to what is our definition in terms of the permutation and combination material, okay? So let's take a look at the problem here. Let's take a look at number 5, right? So number 5, again, the first 4 was just kind of review of the terminology. Number 5, this is what they ask you is, a restaurant offer a choice of 4 salad, 8 main course, and 4 dessert. How many possible way, or how many possible 3-course meal are this or there, right? So how many way can we order a 3-course meal at this restaurant? So if you remember this thing here, one thing is, again, a few students ask me, how can they distinguish the difference between fundamental counting principle versus combination versus permutation, right? So unless they ask you how many ways can you arrange something, how many ways can you put them in order, or how many ways can you choose something from some group of number, then if they ask you to choose, like, if I have 3 people choose from a group of 7 or something like that, then will be either a permutation or combination. If you don't have those, which is in this case, do you see that we have 3 categories and we want to pick one of each, right? How many ways can we order this 3-course meal? Which is reminder that this is your fundamental counting principle. And the fundamental counting principle basically tell you that find the total of each group and multiply them together, right? Again, which is in this case, we have the salad, we have a main course, and we have the dessert. How many salad we have, which is we have 4. How many main course? We have 8. How many dessert, which is 4, which is all we do is we take 4 times 8 times 4, which is 4 times 8 is 32. 32 times 4 is 128, which is, again, this is your fundamental counting principle, which is take each of your category, take the total of each of your category and multiply among themselves, right? So again, this is how many ways you can pick 1 salad, 1 main course, and 1 dessert. And again, similarly, let's take a look at this thing here, which is this problem 6 is fundamental counting principle similar to problem 5, but you probably say, well, not really, Mrs. Tran, right? But let's take a look at this thing here. The license plate in a particular state display 2 letters followed by 4 numbers. In how many ways can the license plate be manufactured, right? So looking at this thing here, they tell you that repetition all allowed, right? Meaning if you choose a letter C, you can choose another letter C, right? Repetition allowed, meaning again, you can pick the same number, the same letter. You can pick any repetition you want, right? You can pick AA1111, right? Those will be allowed. But again, how can we connect this to your fundamental counting principle? So you have to ask yourself this thing here, which is, again, how many different categories do we have? Or in this case, how many different slots is this license plate, right? Do you agree that there are 6 slots in this license plate? We have to choose letter, number, meaning there are 6 slots here, which is, again, I have the letter category, and the 4 number, right? So again, in terms of this thing here, in the first letter, how many choice can I pick, right? Between from A to Z, reminder for your alphabet, you have 26 alphabet from A to Z, 26 alphabet from A to Z, and 10 single digit, meaning from 0 to 9, there are 10 individual single digit, right? So given that, that's why we have 26 times 26 times 10 times 10 times 10 times 10, which is you have 6,760,000 different license plates that you can come up with. Okay, so again, this thing here, which is, again, there's no, you don't use permutation, you don't use combination, because they just ask you how many ways can you mix and match your number versus your letter, right? How many different ways can you mix and match those items? Just imagine this one here, instead of say license plates, they can say that in this restaurant they have 26 salad, right? 26 main course, 10 dessert, 10 different drink, 10 different wine, 10 different, I don't know what else the restaurant offer, but again, basically they have those 6 different categories, right? It's just that the number of total is different in terms of number 5 versus number 6. Okay, so again, that's what we have here in terms of the license plates, which is the different slot. Okay, question with this number 5 or number 6 in terms of how we derive or how to use your fundamental counting principle?
No, none at all.
All right. Let's take a look at number 7, which is, again, hopefully number 7, very similar. We can apply that item, which is the fundamental counting principle, to this thing here. But again, let's take a look at this item here is you want to arrange 6 of your favorite city along the shelf. So again, if you still have city, how many different ways can you arrange the city, right? So if you look at this thing here, first of all, if you see how many different ways can you arrange something, you probably say, well, Mr. Tran, you just told me that how many different ways, this is either a permutation or a combination problem, right? And yes, you are right. Because we try to arrange something, this is a permutation or combination problem. And because, again, looking at this thing here, do you agree that we want to arrange your favorite city, meaning your favorite city, meaning there are some important, right? The most favorite to the least favorite, or something in terms of, because we need to arrange them, the order matter, right? So if the order matter, everybody see that this is a permutation problem. But before we attack this permutation problem, let's take a look at this